Greetings folks, welcome back. In this class we're going to look at uniform distribution. This is a symmetric distribution where a finite number of values are equally likely to be observed. Alright, what do we mean by this? When we have the outcome of an experiment having equal probability or equiprobable, what we call in probability language, is when we are going to have uniform distributions. So we're saying it is a symmetric distribution with finite number of values, so we can count them, and they have all outcome have equal probability of happening. For example, if I want to guess your birthday, I have the all day in the year to guess with it. So the probability of I taking a specific day in the year would be 1 out of 65. So that will be a uniform distribution. Notation: when we say uniform x, okay, random variable x follows uniform distributions with a comma b, we are saying this random variable x follows uniform distribution with lower limit a, this is lower limit, and this is upper limit. For instance, if we are talking of uniform distribution of x, and this x let's say is face of dice, then we're going to have a as 1 and b as 6. Alright, a as 1, b as 6. So we'll be saying x, random variable x, follows uniform distribution with 1 as lower and 6 as upper limit for distribution. Parameters are a and b, where b should be equal or greater than a, because we said one of them is upper limit. And probability mass function is 1 over n, right, where n is b minus a plus 1. So to get the probability of any value, for instance, probability of x is equal to 1, b equal to 1 over n, and we have said n is equal to 6 minus 1 plus 1, so it would be 6. So 1 out of 6, the probability of getting this. Mean of uniform distribution is equal to a plus b over 2. So it would be 7 out of 2, which is equal to 3.5. But since all the values have equal outcome, alright, all the outcome have equal probabilities, then this mean might not be very useful. These expected values might not help us. In fact, what this expected value is not something that would really interest us, because expected value of this x, which is equal to a plus b over 2 in our case, which is equal to 1 plus 6 over 2, which is equal to 3.5 is just the middle point of the distribution. Let's try to and before we look at variance, let's try to look at the probability distribution frequency or probability frequency distributions of this event. All of them are at 1.1 out of 6, right? So we can get 1, we can get 2, we can get 3, we can get 4, we can get 5, and we can get 6. Alright, so let's have here at 1, here at 2, 3, 4, 5, and 6. So you can see all of them have equal probabilities. Alright, and when you look for the expected value, you get 3.5. so perhaps something like this. So this is what they are meaning by 3.5. so this is 3.5 as the mean. It is just the middle point of the distribution, so it 3.5 itself is an outcome. It is treated like an outcome, so it won't be very informative. And also the same with the variance. So variance of our uniform distribution is 1/12 b minus a squared. You can look at this and get the values. Of course, standard deviation would be equal to b minus a divided by square root of 12. Alright, or this one can be b minus a squared. Alright, okay, yeah, this is it. This is our standard deviation. So look at how you can get both for uniform distributions. There is no much inferences that come out of uniform distribution, but it is important you understand which type of outcome that follows uniform distribution. In our next class, we are going to look at Bernoulli distribution. Thank you and see you there.